Hello everyone and welcome to Robotics 2. In this example we're going to do this solve this problem a third way by taking the cross product of yet another variation of it by basically moving the transformation matrix into the cross product. So let's see that. So we've got I dot is equal to I R dot B plus IB omega I cross ITB BB RI. If you're not familiar with this notation, I recommend you watch one of my other videos where I explain the notation. So that way you can see where these vectors come from. I'm basically just going to run right through this example and crank this out. If you have trouble, pause the video and see where I got the certain vectors for this. So this is going to be equal to 0, a vector of 0. Because IIRB is just a translation, the derivative of it is constant. This is going to be 0, 0 theta dot because we only have a rotation about the z-axis. Cross with the transformation matrix here is going to be cosine of theta minus sine of theta, 0, sine of theta, cosine of theta, 0, 0, 0, 0. And that's going to be multiplied by 3, 0, 0. This is a rotation about z, a standard transformation matrix for a rotation about z, which is the only thing we have here, multiplied by this vector right here, crossed with basically the angular velocity about a certain point when you rotate about z of theta dot. So this is the angular velocity about I, and then this is the angular velocity of I with the point I with respect to I in reference to B. So that's a long outlined way of saying that, but basically just take this, find the transformation matrix, cross it with the rotational rate, the angular velocity about that particular point. Alrighty, and then solving this all out, you get 0, 0 theta dot crossed with 3 cosine theta, 3 sine theta. This is negative 3 cosine theta, sorry. 3 cosine theta, and 0. Then solving this all out, that's positive 3 cosine theta. Yes. Apologize for that. And then I R dot I, doing this cross product right up here, this will yield negative 3 theta dot sine of theta, 3 theta dot cosine theta 0, which is the exact same answer we got in the last two workings of this problem. So basically you can play around with what you have and what you want to know and how you want to solve the problem by moving this transformation matrix into different areas of it. You can either set this all up and take the differential of the standard positional vectors, or you can take the rotational vector and cross it with just the positional vector of I with respect to that and then multiply it by this transformation matrix, or you can move this transformation matrix into the cross product and multiply it out. There's really just 10 different ways you can possibly do this, and these are 3 of the most common. Pick the one you like the most. That's pretty much all this is saying.